Well, we're still doing angles in the Cartesian plane, okay, in grade 10 trigonometry. Now, exercise 8, the question says that if sine of theta equal to 3/5, and that theta is between 0 degrees and 90 degrees, determine by means of a diagram cos squared of theta, 2tan of theta. All right. Now, when they say by means of a diagram, I will we can draw a Cartesian plane, or we can just draw a triangle here, a right angle triangle. I think I just want to draw a right angle triangle. I'm gonna draw a right angle triangle here like that. You know, we have it there. That's the right angle triangle. And now when we see that sine, when they say sine theta, when sine theta equal to 3/5, and that 3 and 5 are 3/5 is the simplest form of this fraction, because we cannot simplify further. We understand that this is just the opposite side over the hypotenuse. Okay, you know, sine of the angle is opposite over hypotenuse, therefore opposite side is 3 and then hypotenuse is 5. Okay, so in this case we'll say the opposite side, if my angle theta is over here, theta, opposite side is 3, this side, and the hypotenuse is 5. Now we can use Pythagoras to find the missing side, okay? This adjacent side to the angle. If we do Pythagoras, we're gonna get 4 there. Okay, if you're not too sure, you write the formula there. R squared equal to x squared plus y squared, okay? You know, and then R is 5, so it's 5 squared. And then x squared is the unknown we're looking for, and then y squared is it's gonna be like 3 squared. Okay, so the hypotenuse and the opposite side. Then we can then calculate the value of x squared. If, for instance, we move 3 squared over 5 squared is 25, okay, equal to x squared plus 9. So if I move 9 over, it's going to be like that. And then we can still solve this by, it's going to be like x squared equal to 16, okay? And then to get the value of x, we can just square root both sides. Then x will be, it's plus or minus 4, but you know, sides are always positive. So it's going to be like 4. So that's why we said this part's going to be 4. Now we can answer the questions. Question 1, for instance, let's see cos squared. What is cos squared of the angle? First of all, cos of the angle, we know that cos, let me erase this. We do know that cos of the angle is given by adjacent side over hypotenuse, okay? Cos of the angle is adjacent over hypotenuse. Adjacent is x over hypotenuse r. So this will be like cos of theta will be equal to adjacent side is 4 over hypotenuse, which is 5. Okay. Then cos squared will be, then this raised to the power of 2 is going to be it's going to be 4 over 5, okay, to the power of 2. And then that makes cos squared theta will be 16 over 25. You see? We can also do the same with 10. Question 2, we talk about 2 tan theta. So we do know that tan of an angle is opposite side over adjacent, which is sometimes written as y over x. So the opposite side here is 3, because opposite the angle. So tan theta will be 3 over adjacent, which is 4. Now 2 tan, it means we times also this side by 2. We times 2 times 3 over 4. and then this will make 3/2. So this is the answers of this question. Thank you. Well, another question here says, if tan theta is 5/12 and sin theta is greater than 0, determine it by means of a diagram, 13 cos theta, cos squared plus sin squared. Okay. Now, I can draw my diagram here again. Let's say it's the right angle triangle over there. Then, when the question says, tan theta is 5/12, understand that tan of the angle is equivalent to opposite side over adjacent side. Okay, so if my angle theta is there, or sometimes this is called y/x. It's y/x. So if my angle theta is over there, I'll say that opposite side is 5, so 5 is there, and the adjacent side is over here, it's 12 units. Now we can still use Pythagoras. Let me write the Pythagoras theorem here. It's r² equal to x squared plus y², or c² equal to a² plus b², or sometimes they write h² to say the hypotenuse. Okay, h² equal to adjacent side squared plus opposite side squared. So all this talks about the Pythagoras theorem. Now move a little bit like that, and then we can find the hypotenuse by using that formula. So we'll have like r² will be equal to 5², or it doesn't matter, but I prefer to start by 12² plus 5², and then r² will be equal to 144 plus 25, and then r² will be equal to 169, and then if we square root both sides to find the value of r, and then we get r will be equal to 13. So this part here is just equal to 13. Then we find all the sides of the Pythagoras theorem. I mean all the sides of the triangle. Then we can start answer the question. Like question 1, for instance, when they say 13 cos theta, I know that cos of an angle is equal to adjacent over hypotenuse, okay, or x over r. Now we can substitute that cos theta will be equal to adjacent is 12 over hypotenuse 15. Okay, then 13 cos theta will be I say 15, I meant 13 there, over 13. So it's gonna be like 13 times 12 over 13. You know, these two can simplify it, and then the answer is just 13 cos theta will be equal to 12. So question 2 says that cos squared theta plus sin squared theta. Okay, I think still in grade 10, somehow you learn about some trig identity. If you're not in grade 10, you're gonna do it in grade 11 and grade 12. They call it trig identities. So there's a specific formula for cos squared theta plus sin squared theta. You will learn that this is always equal to 1. Okay, cos squared plus sin squared, or sin squared plus cos squared, is always equal to 1. But now let's prove it. Assuming that we don't know it, because in grade 10 you don't learn it yet. Cos squared, we did find that cos was 12 over 13. Okay, so sine will be 5 over 12. So now let's first solve it. So it's gonna be like 12 over 13, that cos, okay, and then squared, I want to set it to the power of 2, okay, and then sine, we're gonna do the same, it's gonna be 5 over 13, still to the power of 2. And then this is what? That makes 144 over 169 plus 25 over 169. And then if you do 144 plus 25, you get 169 over 169. You know, anything divided by itself in math is just equal to 1. So the final answer is just 1. Thank you. Now we're going to do question C. The question says that if 5 cos A plus 3 equals 0, and A is in between 180 degrees and 360 degrees, determine by means of a diagram tan squared A and sin A over cos A. All right. This time we have a condition here, okay? Because of that condition, which is like in before, the condition was 0 degrees. It was something like that, okay? Even though the angle was theta. So here I could just draw the triangle without really making the Cartesian plane. But in cases like this, it's sometimes important, okay, to really draw the Cartesian plane to represent the diagram. So now I'll draw my Cartesian plane, just freehand. Okay, if I want to be accurate, I can just make something like this. Okay. Make 90 degrees. All right. You know that this is but over here it's 0 degrees, there is 90 degrees, and then 180 degrees, and then down there is 270 degrees, and then we back again to 360 degrees. So when the condition says that the angle A is in between 180 degrees and 360 degrees, it simply means that our solution, our triangle, must be in these quadrants here that I'm going to highlight here. It's going to be this part, okay? It's going to be either on the third, okay, or on the fourth quadrant. Now let's see, where am I going to draw my triangle? They say here 5 cos A plus 3 equals 0. Okay, over here, I can write, I can move the 3 over, okay? So it's like 5 cos A equal to -3, okay? So if I need to get cos A, I can just divide both sides by 5, and then I have left with cos A equals to -3 over 5. And this is even true because remember what we did earlier, the cos function is positive only on the first and on the fourth quadrants, okay? And it's negative here and negative there. Our answer is negative. So the solution, excuse me, because the answer is solution, because the answer is negative, okay? Our solution can be on the third quadrant. But now, let's continue saying, I need to draw to represent this now. We have like -3 over 5. So I know that my answer can be over here or there. This side, when we said we did find that cos of A is -3 over 5. Let me just erase this now. This means that and then 3 and 5 are the simplest form. So this is adjacent over hypotenuse, okay? So remember the hypotenuse is always positive, cannot be negative. So it's -3 that we're going to consider here. It's -3 there. So from 0 to there, it's 3 units. And then there, we are going to make a triangle. Hypotenuse is from the center, okay, to there. And then we have our triangle in the Cartesian plane to look like that. So now this is 5 units. And then this is what we don't know. We can find it by using Pythagoras, okay? Pythagoras use this formula, okay? You substitute 5 here and then 3 there. So we can find the missing side. H squared. So I'm gonna say here H squared equal to hypotenuse squared is equal to opposite side squared plus adjacent side squared. So we sub in there, that's 5 squared equal to adjacent side is 3 squared plus opposite squared, that makes 25 equal 9 plus O squared, move that's gonna be 25 minus 9, that makes O squared. And then that makes 16. O squared is 16, so meaning O will be equal to 4 if we square root there. So no, this part here is not, this part is just equal to 4. Then but remember it's downward, so it's gonna be like over here it's -4. Like there it was a -3, the whole unit is 3. Okay, the triangle also it's 4, but there by the point -4. Now we can start answer the question. So we need 10 of the angle. Okay. Question 1. The angle is theta there. Excuse me. Then we know 10 of the angle is given by opposite over adjacent. Then I'm gonna write the formula there. 10 of theta equal to opposite over adjacent, sometimes y over x. So so 10 of theta will be equal to 4 over 3 raised to the power of 2, because it is there to the power of 2. This will make then theta will be equal to 16 over 9. Okay, that was question 1. And then question 2 says sine A over cos A. You know that this is just sine A over cos A. We have mentioned that already. This is just equal to 10A. Okay, sine over cos is just 10. You can just say this is equal to 4 over 3, even if you say -4 over -3. So this is just 10A will be equal to 4 over 3. Okay, thank you. Well, we have another question here, question D. The question says that if 8 tan theta plus 15 equals 0, and then theta is in between 90 and 270 degrees, determined by means of a diagram sin theta plus cos theta, 34 sin theta minus 17 cos theta. Now, when I look at the condition is that theta is between 90 degrees and 270 degrees. I'll start by drawing my Cartesian plane. I'll draw Cartesian plane over a vertical line here, and then an horizontal line over here. Now, Let me move it a little bit there. Now, we have like 18 over there. We have like 18, 8, 10 theta plus 15 equals 0. Okay, on the right here, 8, 10 theta plus 15 equals 0. So we move 15 over, that makes negative 15. And then if we divide both sides by 8, okay, by 8, we cannot simplify this further, so we can just say 10, its opposite over adjacent, okay? Or sometimes known as y over x. So I am going to draw my triangle, but now you need to take this into consideration, 90 degrees to 70 degrees. So we know that our solution must be in this, must be this side. Our triangle must be this side. Solution is this side. Okay, it's over here. Then okay, we have like opposite is 15 over 80. So my triangle can be on the third or on the fourth quadrant. So how will I know where to place it exactly? I know that be careful with this negative sign. It's not like, sorry. Careful, the negative sign is not just by 15, it is actually on the fraction line, okay? It is there on the fraction line. Now, look, if for instance I said the opposite, a fraction is negative if either the numerator or the denominator is, let me just show you here. If I have like negative 1 over 2, I'll write like this, negative 1 over 2. This is the same thing as 1 over negative 2. And this is the same as negative a half, just like that. So we don't know exactly where the sign, which one was negative, the numerator or the denominator, but what we do know, the fraction itself is negative, like the same case with this case, with this one. We have a negative 15 over 8 here, but I don't know originally which was negative, the numerator or the denominator. We can see that in the quadrants here. If, for instance, I said it was negative 15, it means the negative 15 is the opposite side, okay? The y. It means I'm gonna draw, it's gonna be by there. But now, there is a positive 8. This side, positive must be on the fourth quadrant. But the fourth quadrant is outside of our rank, so it cannot be 15 negative. Now let's put 8 negative. So if I put like 8, let's put like the denominator negative, it's gonna be like negative 8 this way, okay? And then 15 positive, meaning it is up. That makes sense. So I will say negative 8 was over here, negative 8, okay, and then positive 15 there. Now we can just connect the two. I will draw my triangle this way. Okay, knowing that this is like yeah. So I'll start trying to remove. Sorry. Yeah, it's this way. Negative 8 there, and then 15 there. So meaning here is just 8 units. And then this 15 unit. Now, I can start, now I have 15, the opposite side, the angle is over here. And then I have the adjacent side. I just need the missing side hypotenuse. I'm gonna use any of this formula here, where I substitute 15 squared plus 8 squared there. We can use a calculator for that. So I don't need to rewrite this all the time. So I can just say 15 squared plus 8 squared. Okay, this is 289. If you square root 289, you will get 17. Okay, let's just do it. Square roots of 289, and then this is 17. Now we know all the sides of the triangle. It's like cooking, you know, you cut onion, you cut tomatoes, and then blah blah blah. Now we're about to start answering the questions. First of all, we draw a diagram to have a better insight from the question. We together with the condition, then we can start answering the question. Okay, now question 1, for instance, says sine theta plus cos theta. I think I should write the formulas over here. We do know that sine of an angle is given by its opposite side over hypotenuse. Sometimes opposite is y over x. And then cos of the angle is adjacent side over hypotenuse. Sometimes this is like x over r. Excuse me, I say x there, it's not really that. I meant to say y over r. It's 10 10 of the angle, which is opposite over adjacent. So sometimes y over x. So to answer the questions, look at sine of theta is sine of theta will be opposite over hypotenuse. So opposite is 15 over hypotenuse 17. So that makes like 17 17 over no opposite is 15 over 17 plus 8 not 8 but negative 8. Okay, negative 8 over 17. Okay, because this is negative 8, remember, it's 8 units, yeah, but we need to be careful when we solve this. Negative 8 over 17, and now the denominator are common, so we can just subtract the numerator. So 15 minus 8 is just 7, so this is just 7 over 17. That's the answer. And now question 2, when it says 34 sine theta minus 17 cos theta, we can substitute. That makes 34. Sine theta is 15 over 17 minus 17 times cos theta is negative 8. Okay, over 17. Now we can simplify, right? 17 gets into 34 twice, and then there we can simplify that. So now we have like a 2 times 15. That times 15 is 30. Minus minus, we make it plus here, that makes 8. And then the answer will be 38. So that's question D. Thank you.